Welcome to the Commvault Foundation and Core Architecture module for technical sales professionals. For your information, a PDF version of this e-learning module can be downloaded by clicking on the resources link in the top right-hand corner of the training window. In this module, you will learn about the core components within the Commvault software architecture and how these components work together to form the Commvault data platform. We will also discuss some of the technical advantages that Commvault software delivers and discuss a high-level architecture consisting of the basic solution components. As discussed in the last module, Commvault software is a flexible and powerful tool that can be leveraged to bring your customers' data management challenges under control. The software has evolved over many years to address customer requirements as they have emerged. One factor that has allowed Commvault to evolve the solution is that it was originally built on a solid foundation of design goals that have not wavered over the years. As customers embrace new cloud-based architectures, they are looking to control their workloads and datasets as they span both inside and outside of the data center. Many of the technologies Commvault software provides are dependent on the optimization of the movement and management of data. Commvault has always strived to find the most efficient ways to transport and manage data in customer environments. From the early days of being pioneers of technologies such as source and target-side deduplication and OnePass, to technologies of today such as block-level backup and hyperscale architecture. Another key area of focus has been to minimize downtime and accelerate the time to recovery of data for business continuance and disaster recovery. One of the areas of discussion in this module will be around our distributed split-index architecture, which inherently provides organizations a faster path to recovery. Protecting and managing data is an important piece of the puzzle, but one of the areas where Commvault software drives operational efficiencies for our customers is through our capability to deliver both orchestration and automation that minimizes the infrastructure and efforts required for information management operations. Commvault software paves the way for organizations to activate true value from their data by the transformation to a more open content platform used for analytics, federated search, and business protection applications. As you will see shortly, Commvault software's architecture is built for resiliency and provides organizations the flexibility to create robust, protected environments independent of the location or hardware that it resides on and manages. Let's take a quick look at some of the core infrastructure components involved in a Commvault solution architecture. Each of these components will be covered in detail momentarily. Although the multi-tier data management architecture depicted here may not appear to be unique, you will shortly discover some of the key differences that set Commvault apart. As a whole, the components in a Commvault software environment constitute what is termed as a CommCell. Every CommCell starts with a CommServe, which acts as the command and control center in the CommCell. Every Commvault environment has a CommServe as its foundation. The admin console is a powerful web-based user interface that provides a simplified, service-oriented approach to managing on-premise and cloud infrastructures. Admin console offers an easy-to-use and flexible interface that features out-of-the-box configurations that streamlines procedures and automates common tasks. The MediaAgent is the data transmission manager in the CommCell environment. It provides high-performance data movement and manages the storage targets. The CommServe server coordinates MediaAgent tasks. For scalability, there can be more than one MediaAgent in a CommCell environment. The MediaAgent software can be installed in physical, virtual, or clustered environments. Systems whose data is managed by Commvault typically leverage a software package known as a server. Software packages known as agents reside on the servers and provide the native file system and application awareness that allow for successful data management operations such as backups and restores. Finally, a storage target is where data is stored when it is backed up. Disk, tape, and cloud storage can all be configured as a storage target. Commvault indexing and data packaging technologies are tightly integrated with these storage targets to provide a global, virtualized storage repository. The CommServe acts as the command and control center of the CommCell and handles all requests for activity between MediaAgent and server components. The CommServe serves 4 primary functions. It holds the centralized configuration database and metadatabase for the CommCell. The metadatabase catalog housed in the CommServe includes metadata about the nature and location of the data that is stored. It also acts as the central point of disaster recovery in an environment. The CommServe houses a Microsoft SQL database with configuration and media association, which in a disaster recovery scenario is the first item that needs to be recovered. Event orchestration. The CommServe also houses the centralized event and job managers that handle the orchestration of various operations within a CommCell. Finally, the CommServe handles all the management of security profiles and authentication processes. This is managed through local user security groups or through tight integration with external domains such as Active Directory. The MediaAgent is a high-performance data mover server component in a Commvault environment. The MediaAgent acts as the gateway between data streams from the servers being protected and the storage targets where backup data will reside, and then transports that data to a broad range of storage targets including disk, tape, or cloud storage. MediaAgents are also used during auxiliary copies where data is copied from one storage target to another. The MediaAgent maintains granular indexing information in its index cache, which includes detail on jobs and objects it has processed. Part of this maintenance is the periodic pruning of data from the index cache in order to maintain a reasonable footprint. The MediaAgent is also typically the home for deduplication databases in environments. Another function that the MediaAgent handles is that it interfaces with supported primary storage arrays for IntelliSnap snapshot management, which will be covered in more detail in later modules. MediaAgents can be installed on most major operating systems and platforms. For detailed information, please refer to the Commvault documentation website. A server is a system where you have installed one or more Commvault software packages, enabling you to perform data protection and recovery tasks. Commvault Complete Backup and Recovery supports the vast majority of operating systems, applications, databases, and hypervisors in the market. Commvault software packages directly interact with the file system or application requiring protection, and provides the common functionality of Commvault services and utilities. Each server requiring protection will have at least one software package installed. There are some exceptions, whereby a server federates the management of other systems. For example, virtual machines can be protected without requiring the installation of a software package when utilizing the Commvault Virtual Server Agent. The Commvault software packages include the provision of application-aware and application-consistent protection capabilities to ensure the data is protected in a consistent state and is recovered in a valid and usable format upon restore. The last Commvault server components we will touch on are the web server and the web console. The web server hosts the Commvault REST API interface to communicate with the CommServe system. This allows access to the CommCell and end-user operations through the admin console, the web console, and third-party REST API clients. The web console provides web-based applications, including self-service functionality, that allows non-administrative users to perform data management operations such as backup, restore, download, etc. In addition, the web console allows users to, among other tasks, run reports and execute automated workflows. As we have already discussed, the admin console is the web-based user interface for administration tasks. Additional web servers and web consoles can be installed on separate hardware to provide greater flexibility and/or scalability in certain environments. The final Commvault software component we will touch on here is storage targets, A storage target can be one of the following: a disk library that you associate with one or more mount paths. A mount path is a set of partitioned disks or arrays that is associated with a file system. A mount path can be a local disk or network-attached storage device. A cloud library that you associate with a supported online cloud storage device. Commvault is compatible with more than 20 object storage providers. Cloud storage provides the ability to easily increase your storage capacity as and when it is required. It also provides centralized data access, better failover capabilities, and reduces the day-to-day storage administration tasks. Finally, a tape library can be configured that is attached to the MediaAgent. Commvault Software's robust indexing engine provides a common catalog and awareness of stored data regardless of where it resides, where it originated from, or how it got there. Commvault Software's capability to add additional storage as needs demand is not new. Scalability has been a key differentiator of our solution. Storage can easily be added to house data whenever and wherever it is needed. Commvault Software allows organizations to leverage these core infrastructure components to handle a wide variety of information and data management functions, including data protection and recovery, archive of data for capacity optimization purposes, reporting and analytics, the management and induction of hardware-based snapshots into an overall data management strategy, data replication, search and analytics, automation, migration, deduplication, and disaster recovery. These functions may be applied across both physical and virtual environments, for structured and unstructured data, both on-premise, in the cloud, and at the edge, spanning different server platforms, hypervisors, applications, and disparate storage platforms. With Commvault Software, organizations are able to leverage shared infrastructure, consolidate and centralize the management of these functions, apply common processes across their environments, and maximize their storage efficiency by leveraging global deduplication. Effectively, this allows customers to minimize their learning curve associated with data management, design for availability and disaster recovery in a holistic fashion, and minimize the amount of times that data requires processing. By doing so, the deployment of Commvault Software can drive significant economic savings for organizations, as well as dramatically increase the efficiency of their operations. Now let's move on to a discussion around Commvault Software's unique indexing methodologies. A discussion on indexes may appear to be dry at first glance, but is actually very important in understanding how Commvault Software provides resiliency and maximizes infrastructure efficiency in environments. There are 4 areas surrounding indexing that we will touch on. As was mentioned in the previous section, the CommServe houses the CommServe database, a relational database built on SQL that contains much of the critical metadata for a CommCell environment. Information such as scheduling, storage policies, activity, media management, reporting, security, and encryption is housed in the CommServe database. It is important to note that the database only houses this lightweight metadata, which allows Commvault to maintain a small footprint for the database. MediaAgents are where the index cache and in many cases deduplication databases are stored. Recommendations for sizing index cache volumes are included on the Commvault documentation website, which should be referred to for all sizing recommendations. The index cache contains detailed job and object index information and characteristics. For example, exactly where a particular piece of data is being stored on a storage target device. The deduplication database maintains hash records for deduplicated storage policies. The index cache is maintained locally by the MediaAgents themselves and automatically protected like the data itself to a storage target. So why does it matter? First of all, by distributing indexing across multiple layers, it minimizes the footprint of capacity consumed by the indexes. Even in very large environments, the CommServe database maintains a minimal footprint. This allows for portability, and disaster recovery backups of the CommServe database are easily conducted to remote locations over a wide area network. A disaster recovery CommServe may be configured in a cluster arrangement, or it can be virtualized to minimize cost. As mentioned, the fact that the index information is also written to each storage target contributes to the resiliency of a Commvault software environment. In the case of a failure, a different MediaAgent responsible for a secondary copy of the data will also contain all of the indexing information required to perform a recovery. In a disaster recovery scenario, these capabilities, which are provided by Commvault Software's distributed indexing capabilities, result in a highly accelerated time-to-data recovery. Many alternative solutions in the market have monolithic databases that can grow to very large footprints. In a disaster situation, the advantage of the smaller CommServe database becomes apparent. When a disaster transpires, the first step is to recover the CommServe database. Given its small footprint, the time required to restore this database is minimal. Once the database is restored, the CommServe will communicate with the MediaAgent, and the MediaAgent will initiate the restoration of data and servers. When directly compared to competitive solutions, customers see that the restoration process of their servers and the data on those servers is being initiated well before many competitive solutions have even finished restoring the database. This is a technical differentiator that has convinced customers many times and has won many proof-of-concept engagements for Commvault. The efficiency of data restoration and the time to recovery are critical aspects when choosing a data management solution, and Commvault software is head and shoulders above the pack in these regards. Another key concept we want to take a look at is how Commvault software handles the recovery of data in a single pass. To convey this process, let's take a look at a simple data protection operation. In this example, a MediaAgent communicates with a server to determine the data that needs to be protected. A full backup of the data is then conducted. Thereafter, incremental backups are conducted. In this example, 4 incremental backups occur subsequent to the full. Let's assume that at this point in time, the server experiences a catastrophic failure and needs to be recovered. Commvault MediaAgents index all data being written to the storage target, so the administrator can view all backed up data from any point in time, regardless of backup type. When the recovery process is initiated, Commvault software looks at the most current version of objects that were present at the last backup and identifies those objects. The MediaAgent index is leveraged in order to gather the most recent copy of each file in the backup, and these files are utilized to conduct the system restore. Commvault software intelligently knows how to combine the latest full backup with incremental backups to present a point-in-time image to browse for recovery needs. In this section, we will cover a number of key areas to help understand Commvault deduplication and the benefits that it delivers. Source-side deduplication, which is also commonly known as client-side dedupe, leverages a client-based disk cache known as a source-side deduplication database, which contains the signatures for the data blocks relative to that particular client. With source-side deduplication, redundant data is identified at the client and is reduced prior to the network transmission of that data. Target-side deduplication, on the other hand, conducts the comparison process via a deduplication database resident on a MediaAgent prior to writing data to the storage target. This is similar in fashion to many deduplication appliances which bundle a server, software, and storage in a single target device. Commvault follows a similar methodology to our distributed index functionality discussed previously, with the distribution of deduplication record information. When a particular piece of data is written to the storage target, the signature and location information relative to that object or job is also stored with it. This allows us to only use the deduplication database for check-in or lookup processes only. An important differentiator is that the deduplication database is not required to restore any particular piece of data. It is key to note that with Commvault software, customers do not have to make an all-or-nothing decision when it comes to the type of deduplication appropriate in their environment. Both source and target-side deduplication may be designed in a customer environment to suit their needs. Dash copy is a technology that enables the transmission of data in its deduplicated, reduced form factor between media agents. This includes the capability to recover data and maintain different retention periods, both independently from the primary copy. This reduction in bandwidth consumption facilitates disaster recovery and also eliminates the need for vendor-specific appliances or array replication for disaster recovery purposes. Commvault software also provides a global deduplication capability, wherein copies of data from multiple storage targets may be combined together and referenced through a centralized deduplication database. This is achieved by creating what are known as storage pools. This allows customers to collapse wider groups of common data into a global pool to maximize the level of efficiency with deduplication. Increased deduplication efficiency is achieved by way of having a larger common pool of blocks to reference against. It also provides customers a great deal of flexibility and allows them to design fan-in scenarios to maximize the utilization of storage targets. A global deduplication storage pool can span secondary sets of dash copies in a single data center repository as depicted in this diagram. Commvault software is also renowned for its scalability. As the number of clients being managed in an environment, or the data sets those clients generate increase to a threshold where the original number of media agents cannot accommodate the customer's established protection and recovery SLAs, it is a very simple process to scale the environment by deploying additional media agents to accommodate the load. This core architecture also facilitates back-end scaling of deduplication and non-deduplication storage targets. As an environment grows and more capacity is consumed, Commvault software alerts users and allows them to easily add additional storage. For example, if a storage pool is nearing capacity, users can add additional mount paths to the storage target in order to seamlessly increase its capacity. These mount paths can potentially be from disparate storage arrays provided by disparate vendors. This also helps to provide our customers with flexibility to balance both performance and cost in terms of the storage platforms they leverage in their environment. Encrypting data is an essential part of a data protection strategy, especially if data is being placed on removable media or stored in the cloud. If data is stolen or becomes accessible to unauthorized users, then sensitive information may be compromised and cause significant risk for an organization. Commvault software is secure by design, providing FIPS-certified encryption functionality that is built into the Commvault data platform, as part of Commvault Complete Backup and Recovery. Commvault software encryption lets customers choose where and when the encryption is implemented, enabling them to meet their own specific security policies. Commvault encryption can even be used together with Commvault deduplication. Commvault software encryption provides end-to-end security, where data can be selectively encrypted in-line during data protection operations. Software encryption can be initiated on the server being protected or on the media agent and remain encrypted when written to the storage target. Offline or copy-based encryption uses Commvault software encryption to secure data during auxiliary copy jobs. Customers can preserve the primary copy encryption or choose to re-encrypt the data with a different encryption cipher if they wish. Hardware encryption allows you to encrypt data on tape drives that have built-in encryption capabilities. Commvault software supports a wide variety of encryption algorithms based on the required security and performance as depicted in this table. Finally, you can protect Commvault software encryption keys using supported third-party solutions from SafeNet and Vormetric, as well as AWS and Azure key management servers. We will finish this module by covering a couple of key concepts surrounding logical components in a Commvault environment. Plans, configured through the Commvault admin console, are used to simplify data protection, In a plan, you define what to back up, where to back up your data, and how often to run the backup job. There are plan types that include the data protection parameters that apply to the type of data you want to protect. Base plans act as templates to create what are known as derived plans. You can also set the default plans that can be automatically assigned to new servers to ensure your data is protected. Plans are mapped to service levels. After the backup frequency and the backup window are defined, Commvault uses automatic scheduling and dynamic priorities to achieve your defined RPOs. Finally, more comprehensive plans can be created for certain use cases. For example, if a customer wants their data to be managed in a very specific way. A server group is a logical grouping of the server computers. You can create server computer groups so that you can define options one time and then have all the options assigned to all server group members. Server groups are created for any number of reasons. Some of the most common reasons are grouping for the sake of security, reporting, automatic updates, geographical management, for example, to allow different schedule policies to be applied to different time zones. Server groups may also be created to accommodate business requirements. For example, different functional groups in an organization may have different service levels associated with the protection of their data. Server groups can easily accommodate scenarios such as this. As depicted here, a particular client may belong to multiple server groups. Finally, server groups can be configured using automatic association that follow a user-defined set of rules. Based on these rules, existing or new servers are added or removed to the server group automatically. This concludes Module 2, Commvault Foundation and Core Architecture Overview. During this module, we discussed the core components within the Commvault software architecture and functions of the Commvault software server components. We also discussed some of the benefits that a unified software approach combined with the Commvault software indexing structure brings to the customer. You will now be required to pass a 5-question assessment to earn credit for this training module.